I'm excited for, so many other people to have that same story you had, where, they see the benefits of electric and they see that they no longer have to compromise. And that takes them down this path where now electric flight and just a cleaner, quieter, more efficient future is at their fingertips. That's what we're all here trying to do. So,
Welcome back to Turn Down for What, your source for EV news and updates. Like and subscribe for more content like this episode. Let's dive on in. Welcome back to Turn Down for What. Another day, another episode. Here we go. Today we are actually doing a follow-up of a conversation we had at the very beginning of the podcast. So episode 7, we introduced Whisper Aero on the podcast, and at that time we actually had Ian in to Johnson City and got to kind of sit down and at our studio and kind of go over some of the exciting things that Whisper Aero is doing in Tennessee and in the advanced air mobility space. There's a lot happening with Whisper Aero and a lot that's gone on in the last year. And so wanted to finally, after 4 or 5 weeks of teasing our audience, finally have a discussion around advanced air mobility, some of the exciting updates that have taken place with your company and some of the recent things that we've gotten to celebrate with you. So, Ian, welcome back to the podcast.
right on. Thanks for having me virtually.
Yeah, absolutely. So give us an update. Obviously, a year ago, we had some conversations about, the consideration for the future of advanced air mobility, the fact that it needed to be considerate, needed to be quiet, and we had talked about some of what your team was working for as far as advanced, basically thrust in and figuring out how to do that quiet and considerate. So give us some updates in the last year, kind of some of the progressions that have taken place with Whisper Aero, and we can kind of talk about that.
Yeah, definitely. Man, there's so many. It just feels like a lot of things happen in one year here. So I think since we last met, we announced the quietest, most efficient leaf blower on Earth.
Which is
We also,
incredibly impressive. If we can find a clip, I will insert it. But I mean, it's incredibly impressive.
yep, yep. I mean, it not only is so quiet you can operate it at night, but it uses 40% less power than, an equivalent electric blower and blows 40% more air than even some of the gas blowers out there. So it's pretty insane. So we've got that. We announced Reconnectin. Reconnectin is a regional air mobility coalition formed around Tennessee with you guys as well, as you well know, to help push forward uh, regional air mobility in the volunteer state. And we've brought together not only folks here, TDOT, you guys, Whisper, but we're also bringing in folks across industry like Reliable Robotics, um, Avports, and a number of other folks who are just big players in this space who want to see this industry grow and be able to show how we can really transform the way that we move every day, right? Like there's 90% of all trips coming out of just 70 airports across the US, and we can definitely change that. The leaf blower, Reconnectin, we recently opened up our brand new flight test hangar in the heart of Crossville at Crossville Airport, which is pretty amazing. That's an 8,000 square foot space. Um, we demoed a bunch of our hardware recently, showed off our largest propulsor to date and demoed it, blew some people away. And
Literally.
literally,
Yeah.
literally blew people away.
Here is the non-whisper one. And now let's listen to the whisper one. This is not the largest one they have, but an example. I mean, listen to how much quieter that is.
And we've since moved into a brand new space. So we used to be in Mark's resort, Mark, my CEO's resort, um, that we converted into a secret lab over, the last 3 years. We outgrew it. And so we moved into a 40,000 square foot space as part of Tennessee Tech's larger 123,000 square foot Crossville campus and have turned that into our new manufacturing test line as well as a static test facility, which is amazing. We also just was it was it last week or maybe this week? We just showcased some of the work that we were doing with Oak Ridge National Labs on their supercomputers, um, really showing how we're leveraging this advanced supercomputing capability to drastically increase and accelerate some of the high fidelity simulations we use in house to be able to design the best and quietest fans on them.
Yeah.
Um, there's a lot of other stuff too, but I don't know if we can talk about that.
Yeah.
So we're gonna keep that for the next pod.
Absolutely. Yeah. Well, I mean, we were had the privilege of being at your guys' grand opening, and obviously, big accomplishment to get the hangar open and the flight testing center ready to go. We're excited to kind of see that side of things develop. But obviously, as you alluded to while you were there, you kind of blew some people away with some of the technology revelations that you guys have produced since then, and that's where on display there we had the leaf blower, and you've taken to some of your expos and stuff, but the actual comparison of the gas powered, I mean, you had 3 or 4 different types of regular conventional electric and gas powered leaf blowers, but then turning that around and actually showcasing off your technology, which a lot of people, I think, would have the wouldn't have the thought to think, hey, the same technology that's going to take an airplane off the ground is going to be used to blow your yard. But at the same time, I mean, it's the same. It's thrust, and I mean, you guys have done it very well, and it showcases the fact that technology is what you guys have developed is, I mean, insanely impressive. Do you guys have that leaf blower coming to market soon?
Soon, we have some announcements that we're planning in the fall. Can't say too much yet. Um, what I can say is, we built these proof of concept leaf blower. We use, some pretty fancy computational um, methods to not only scale the tech down, but then also figure out how we low cost it and make sure that it becomes a product that is affordable for the masses. And that nuance, that key innovation in how we low cost it using injection molding and advances in new materials, that was where we spent a lot of time earlier this year, late last year. So we don't want to become a leaf blower company.
Yeah.
The core of it is propulsion. We're going to end up licensing this tech to a big name. Can't say who just yet. And through that licensing arrangement, we'll be able to, actually get our tech in the hands of people around the world to, hopefully ensure our neighborhoods are cleaner, but also we all sleep better on the weekends and we don't hear leaf blowers while we're recording podcasts,
Yeah.
um, all over the place.
And
Leaf
I mean,
blower
go
leaf
ahead.
blower was my gateway drug into electric. It was the first electric thing I bought was when I bought my house was an Ego leaf blower, which then led me to an Ego mower, which led me to an Ego trimmer. And I've got a whole collection now of things, including a big box fan. And so I can definitely imagine that scaling and the number of times, even as quiet as the Ego is, it's still pretty loud. So the idea of that being even quieter, because when I hear a gas leaf blower from the neighbor, it's like shockingly loud now compared to what I have. And so the idea of that becoming quieter, the idea of drones, the DJI drones and things that people use, those things as they get popular, to have that be quieter. I mean, I can't wait to see where this thing goes. And I love that you're just taking a concept and being able to scale it, because that's what's important is people see cool gadgets and toys, but if it can't be mass produced and scaled, then that the cost is just too high. So if these majors are getting involved with you guys and being able to scale this stuff into high production, it's just limitless what it can be used for in all the different applications. That's exciting.
That's right. And I'm excited for, so many other people to have that same story you had, where, they see the benefits of electric and they see that they no longer have to compromise. And that takes them down this path where now electric flight and just a cleaner, quieter, more efficient future is at their fingertips. that's what we're all here trying to do. So,
And the big thing is, I mean, the technology one, like the efficiency side of things. I mean, you're using less energy, which on a leaf blower you can recharge the leaf. I mean, the blower itself, but the on the other side of things, when you're dealing with aircraft, we the consideration for efficiency makes a huge difference because one of the biggest issues we have right now with eVTOLs and some of the electric aircraft that are coming out is range. How do we get these planes farther? Because with FAA required, reserve times and how like dealing with some of the red tape that's coming around eVTOLs, you're not able to take them over the distance yet. We're working on getting that, but batteries are heavy. So having heavy batteries and non-efficient fan systems or propulsion systems then makes it to where you have to use a lot more battery energy. But by having more efficiency in the fans, you can have lighter batteries or less batteries, that is, or with the same amount of batteries, have better thrust. And so then you're able to take it farther, faster, which makes and quieter, which makes it's kind of like an all-in-one solution. So from the leaf blower, which, is something that honestly, you cannot put words to it until you're there, see it, hear it, feel it. If you ever have an opportunity to be anywhere near the Whisper Aero product, by all means, check it out. It's impressive. But in the demonstrations they have, I mean, they can stack them up against even the quietest electric leaf blowers, and it's significantly quieter. But that,
and more air,
yeah, and it's
and more air.
it's quieter and it has more thrust. But dealing with that, also taking that technology into the skies, you like you said, Jesse, nobody wants to hear the gas leaf blower next door, but nobody also wants to hear all of these, loud planes and loud drones flying overhead. And so having these efficient platforms then opens up mobility for less cost and farther distances because of the efficiency.
I think Chris is the one that said that, not necessarily me. I don't know where that came from. Now, one other
The,
thing that
these people with
you
hair,
forgot to
man,
mention
the people with hair
is
confuse the
that's
other,
all
the
it
bald
is.
and beautiful
He
all the
doesn't see
time.
anything different. So,
No,
but one other thing I want to mention that you didn't talk about is the 100 passenger design that you released not too long ago as well. Obviously, it's a concept for future designs, but when you look at that, it is probably the most futuristic design of an aircraft since probably the 1920s to the 1950s. That 100 passenger design with the inboard uh, uh, turbines in the wing itself is definitely something that when you look of what the future of aviation could be, that's it. So if you wouldn't mind, go into two areas for me. One of them is the way that your motors are so much quieter is because of the induction lip. Could you explain that technology real quick? And then the second part would be, can you explain the aircraft, both of them that you have designed right now, and where you are in let everybody know what those are too, because I think if somebody saw that, they would not know that's something that's even capable of being concepted today. Oh,
Yeah,
and you are a traditional takeoff where everybody else in this field are eVTOLs. You're a traditional takeoff vehicle, and I think that helps a lot in the efficiency as well. So can you go into that part?
yeah, definitely. Let's dive into it. So zooming out for a bit, I think the last time we chatted, we were talking about this promise for regional air mobility, why it's a great fit for states like Tennessee, and you know, acknowledging the fact that even though there's all these people that are chasing this shiny sort of eVTOL market, that there's a huge market for regional air mobility. Regional air mobility doesn't require vertical takeoff and landing. You can use conventional takeoff and landing, or in some cases, even short takeoff and landing to be able to leverage the over 5,000 airports that are on the continental US. And if you do that, the cool thing about conventional takeoff and landing is you're not using the same amount of power, both peak power, but also overall potentially power for some of these short trips. Instead, you're able to gradually use lower C rates, pull from the battery, take off using a conventional runway. And when you do that, now instead of having to design an aircraft for this really large peak power, you can size it to instead, more gradually pull power from the battery and also size a much larger aircraft that moves more people. So now not only is it, less harsh on the battery, so your batteries last longer, you can move more people around across airports that already exist, not having to wait for these brand new vertiports to get stood up. And by nature of having more people on the airplane, you're amortizing the cost of that trip. So instead of having to, take forever to get to, anywhere from $2 to $3 per passenger mile trips, we can actually get closer to the federal reimbursable rate of driving your car, which is 62 cents. You can dip below that on a conventional takeoff and landing, electrified regional air mobility aircraft as opposed to a much shorter distance eVTOL aircraft. And so understanding that, here at Whisper, we've taken some time to look at this in greater detail, right? Like why try and fight, or compete with some of these other players that have invested a ton of time into eVTOL when there's this vast, awesome market to go tap into that doesn't require the same level of capital. Why wouldn't you do that? And we started by looking at a 9-passenger aircraft that could, be fully certified by early 2030s. And then more recently, we've started to sort of zoom out and look at, what will it take for us to hit net zero greenhouse gas emission goals in aviation by 2050. There's folks out there. I think there was an International Council on Transportation that was doing the math and said, for us to actually hit the 2050 net zero greenhouse gas emission goals, the aircraft that need to be flying in that 2050 state need to be ready closer to mid 2030s. What does that mean then? Well, that means that we've got a whole lot of work to get to even thinking about replacing these 737s, 757s, things that, United, Southwest, all these major airlines are flying today. And so because of that, folks like NASA, the FAA have started to fund these newer sustainability projects. FAA has been looking at something called Fast Tech that sort of spans a bunch of technologies from SAF to new propulsion to new aircraft concepts. FAA has been looking at that. NASA has been looking at something called ACES, Advanced Aircraft Concepts for Sustainable Aviation. And so because of that, understanding sort of there's these two new pushes happening, we went and said, okay, well, how would our tech want to be installed on a 100-passenger jetliner that could make a meaningful dent in hitting those 2050 net zero greenhouse gas emission goals? And so what we did was using that 9-passenger concept that we looked at the last few years, we scaled that up. We said, okay, we know our tech can go higher in thrust. What happens if we went to a much larger electric engine? And also, what if we continue to integrate those into the wing of these aircraft in what we call a jetfoil? What would that aircraft look like? And so that's what you see, and I'm sure you guys can bring up a photo. That's how we got to this 100-passenger jetliner concept. We directly embed these electric engines into the leading edge of these airfoils into a shape that we call the jetfoil. By doing that, we're able to, without increasing the wetted area of the wing, pull in air and then actually take that jet flow, that cool, deswirled, efficient jet flow, and augment the lift over that wing, right? You think about how lift is produced. There's this pressure delta between the upper surface and the lower surface of the wing. We take that air and accelerate it over the top. That then creates a larger pressure delta, which means we can create more lift in the same amount of wing area and still be able to also produce thrust. And so by doing that, you not only get to a more efficient airframe, you're now generating more lift with a smaller wing. And because that wing is smaller, now the ride quality is better because your wing loading is higher. So a lot of exciting things wrapped up into that. TBD when all this starts, but we're hoping that we can really make a dent on it. And before, those programs really kick off at Whisper, we're starting to do the work um, to know that the tech can scale up even further. So at our flight test hangar ceremony, we demoed that 80-pound thruster live, but that's just sort of one stepping stone to get to these much larger thrusters that are producing hundreds of pounds of thrust. And in-house, we've started to do the work to look and see sort of, can we verify the lift characteristics of our electric engines inside a Jetfoil? And it turns out it's looking quite good.
So what is the biggest theoretical amount of thrust that you feel like you could potentially produce? Not that the technology is here yet, but based on the designs that you have, how much thrust do you think the max that you could get if that technology was available?
Yeah, there's always trade-offs. For us, we really want to keep these electric motors air-cooled. We don't want to use liquid cooling. The moment you have to liquid cool the motors, you add weight, you add volume, you add complexity, you add reliability challenges, additional things you have to go look at, failure modes you've got to go think about. We'd much rather keep it air-cooled. And so if you are keeping it air-cooled, that means that on a unit sort of propulsor basis, you're still probably under 1,000 pounds of thrust per electric engine. But the cool thing about distributed electric propulsion is you can use multiple of these engines, right? When you look at this jetliner concept, you have multiple of these electric fans um, embedded in the wing on the leading edge of that wing. And so, if you need to produce thousands of pounds of thrust, you could use multiple of our electric engines instead of having to combine them into a single unit. And it ends up being better, right? You think about cube square law, right? As that motor gets bigger and bigger and bigger, the surface area you have to play with doesn't increase nearly as much as the volume of that motor. So when you think about rejecting the heat, it's much easier to reject the heat with lots of smaller motors than with one large motor because you only have so much surface area for a given amount of volume, for a given amount of windings and magnets.
I mean,
Um,
I guess I mean, we can get into a really detailed conversation, but like from a really like a high perspective view without getting overly complicated, your traditional aircraft, with like, if you just think about a regular plane that's hauling people, larger aircraft, obviously, those things the engines are what, like 50,000 pounds of
Well,
thrust. I mean, like what is that?
a
What is
Honda
that
Jet,
metric?
I think a Honda Jet is only 2,000 pounds of thrust per motor on those. So
Like a private
that's
jet?
just, yeah. So you take something like this, you could put all of them across the wing. You're looking at a huge amount of power.
yeah, I think when we're talking about business jets, there's definitely opportunity to stay air cooled. For some of these larger concepts, it may require some liquid cooling.
But with
It may
the
require some interesting integrations, but it's
with the
still,
spreading of the load, does that make, like you were saying, the lift better to where you don't need as much thrust, or did you still need to equal that roughly same amount to get to the same level of lift? I'm not sure about how the aerodynamics there work.
yeah. So if we take it back to physics, right?
Yeah.
I don't know if everyone here is taking physics, but
Now I'm
there's
in
this thing called
trouble.
there's a thing there's a thing called a free body diagram, and you use a free body diagram to show your forces, right? So if we just imagine a dot, this dot, my hand is the aircraft. I'm just simplifying the aircraft into my hand. Lift goes up. The thing that's opposing lift is your weight, the weight of the aircraft. And then if the airplane is moving in this direction, that's thrust. And the thing opposing thrust is drag.
Yeah.
So um, when you put these thrusters along the wing, the thrusters are producing thrust, but they're also improving your lift. So yeah, you can get to these larger engines, and by nature of distributing them, you're improving the lift, you're improving the thrust. And so the trick is, how can you still minimize the drag and do so in a way that doesn't increase your weight?
Gotcha. Yeah.
And so that's why you have so much more efficiency. You're not pulling or pushing through your drag and trying to create two different things, but you're accomplishing the same thing between two different parts of it, which is fantastic.
Right, right. It's all about stacking these synergies together to create, system-wide synergies.
Yeah.
So to your point, Josh, like we're minimizing the weight for a given amount of thrust by going through this distribution. When you go to these solitary units, these large monolithic engines, whether you're electric or non-electric, right? There's just so much more complexity. You are forcing this complex thermal management problem to get, isolated in one small piece. And that means that if that fails, right, you now have to mitigate all of that in one solitary unit. You're also saying that you've got to like contain or mitigate the heat all in this one, engine, as opposed to having a distributed array where if one fails, great. Well, you've got however many 20 other units to maintain the thrust. It's like,
A lot
okay,
easier to replace too.
yeah,
Yeah.
yeah. I mean,
The
just imagine maintenance workers. Like would you want to replace an engine that's bigger than you or something that you can
less
like
people would get
stick under
sucked
your arm?
into it, I guess, right?
Yeah,
There's those
yeah.
horror stories. It's crazy. I mean, I think that's the one of the considerations, though. I mean, I think with the a lot of people, I've talked to several people and talked about advanced air mobility. Like, well, I'm never riding in that. That's for other people. And I'm like, well, I mean, honestly, if you look at your model, it's safer because in the event that you're taking a single prop up in the sky, the single prop dies, you don't have any thrust and you're done. I mean, like, and I mean, obviously you can coast and there's that whole element, but in a vehicle when you have 20 different propulsors, then in that situation you lose 5 of them, you're still fine. I mean, you might be coasting farther, but I mean, you would take all out failure of all of the units by some catastrophic measure in order to lose all of your thrust, which is I mean, honestly, that actually makes it a safer trip.
Yeah, yeah. Being able to still lose 5 and have 75% of your thrust available is pretty significant.
Yeah. I mean, you could fly on that. So I mean, that's definitely a consideration point. But yeah. So yeah, I mean, obviously with the technology, I mean, we could get into the weeds of all of the depths of it, but to keep it on a distant perspective, you guys are doing some very cutting edge things with the space, and I mean, obviously in the demo of the actual, you said it was the 80-pound. Is that what that unit is that we saw?
Produces peak 80 pounds of thrust. Yeah.
Yes. And I mean, it's impressive to hear. I mean, you put it up against some of the other fans and some of the other technologies. It's impressive to hear how quiet it is to provide that much. And is that the unit that you're using on the drone that you are flying already, or was it the smaller unit that's on the drone?
No, so the drone that we showed, that's a 55-pound Group 2 demo drone. We flew that for the first time in 2022, so it's a much older asset. We were flying an earlier 10-pound prototype fan on that. That 80-pound fan that we demoed there, we showed that integrated onto a glider, a Swift glider. So it looks like a swept flying wing. One of the most efficient gliders out there, has won lots of glider competitions internationally, which is pretty cool. But we're using that as a test bed for customers that may want that either for the DoD or may want to use arrays of these 80-pound thrusters to build a relevant regional air mobility aircraft that is electrified and can actually start to make a dent in our sustainability goals.
I mean,
So
the elephant in the room there is what you just said with DoD, because when you think back to the days, I think of where my dad grew up in Palmdale, and they had the skunk works out there for Lockheed. And that stuff that would get developed eventually makes its way into commercial and eventually makes its way into private aviation. But where some of that technology leap happens and really gets refined a lot of times, and where the budgets exist for that type of thing, is in those DoD programs, those local municipalities, everything from out here in California where we have the fires up in the hills. We use drones to go out and look at those areas, or whether it's local police and having drones to look at different sideshows or different protests and things. And then of course DoD and what they do overseas, you can absolutely see the need for efficiency and for quietness, and those two things in combination, they often get refined in those DoD programs and then implemented into the stuff that we would use as private citizens. So Has that been something that I don't know what you could even say if you could, but is where those types of contractors have been involved and in contact and looking at this stuff?
Yeah, so we are working the DoD side. I think what I can say is nobody's ever asking for less range or less speed or less survivability. So if you've got a solution that enables that, that it enables, a more efficient flight, that allows you to carry more payload, that allows you to do more things with
Or be very
uncontested
quiet.
advantages. These are all things that a customer may want.
The whisper part of that arrow can be very important in certain circumstances.
I think we had given a couple examples on the last episode with you, just kind of referencing the height difference. I think with the applications there. I mean, you can be so much more silent at lower paces, where your engine, I mean, you can be 10 times lower and not hear it because of that. I mean, that makes it where you can get better imaging, better surveillance. I mean, it's a really good application for um, consideration for the average person in America, but for stealth purposes, I mean, that's a huge benefit, because I think one of the biggest things that you look for in military advancements and DoD applications is the stealth side of things. You don't always want to come in loud and loud and in charge. It's a matter of how you get in and get it out quietly. And so having that type of technology is definitely a huge win for that application alone.
Yeah, and I think that leaf blower is example of that. You're taking technology that is designed to move aircraft and putting it in a leaf blower. So it's still that adoption of that tech into other things that we could use every day.
Yeah, if you look at the history of aerospace, there have just been all these innovations that start with the government, that eventually find their way into, our everyday lives. There's tons of examples of this, like, aerogel. That was at NASA. They developed that for just experimentation purposes, and now we're seeing useful reasons to integrate that as an insulator for even things like shoes. Saw that at a trade show recently. That's kind of amazing. I think for us, we look at the arc of flight, and I say this a lot, but some of the biggest step changes in flight, they are often preceded by step changes in propulsion. So no brainer, if you want mission success, if you want a better flight profile, if you want to ensure that you can fly and accomplish the things that you need to go do on a day-to-day basis, whether that's moving people or cargo, whatever it is you're trying to do, deliver chicken McNuggets, you got to start with a better propulsion system. And by nature of having that propulsion system, that opens the door to more affordability, to faster speeds, to longer range, and really to getting to the kinds of experiences and things that all of us want to have.
So, I mean, kind of to shift gears a little bit, you obviously having a prominent name, in your company having a presence in the advanced air mobility space. A year ago, we kind of had alluded to this question, but where do you see the roadmap? I mean, like we had talked about earlier, there's all these players jumping in with eVTOLs. You have all these, I mean, they're getting certified, they're starting to get produced. I mean, we're on the cusp of seeing advanced air mobility as an actual reality. How do you see the roadmap with your as perspective of advanced air mobility as a whole? Because our audience, I think, we talk a lot about electrified vehicles and, what the Ford F-150 Lightning does. But looking at advanced air mobility, I don't think a lot of people realize how close we really are to seeing electrified aircraft in the skies. So what do you see as the roadmap, the first use cases, and how is that going to progress? I mean, it's a loaded question, but
No. It's a great question, and I think it's something that people ask about. And the vision has been, a lot of the things about the vision have been the same. The specifics have changed over time, so it's a great question to ask. Um, right now, the lion's share of electric aviation is focused and wrapped around these eVTOLs and urban air mobility, trying to figure out how we're going to actually kick off this air taxi market. You're right that there's players like Joby and Archer and Beta who are flying electric aircraft today. Joby and Archer are probably the furthest along when it comes to a meaningful, full-scale VTOL aircraft that has done repeated transitions and shows a path to market viability. For them, they're definitely in the thick of it with the FAA, trying to figure out how are we actually going to fully certify these aircraft. Um, they're very far down the road, right? They've gotten the means of compliance. We're now starting to talk about SFARs for the aircraft. And then at some point, they're going to need to show that they meet all of those means of compliance, which means, hours and hours of tests that map back into the things they said they would go do, that map back into showing that they're actually as safe and reliable as they say they're going to be. But then on top of that, they have to think about production cert. How can they prove that not only is the aircraft safe, but we can produce these aircraft at a meaningful scale that we say we can, and also ensure that the quality of each one coming down the line is just as good as that first one that they used to qualify and certify. So we will probably see some of these first aircraft from Joby and Archer get certified in the late 2025, maybe 2026 timeframe. A lot of that just has to do with the federal government, the regulators, how fast and how thorough they can be in ensuring the safety and reliability of these systems. So, outside of just the US, I think they're looking at de-risking that approach. Both Joby and Archer have started to look at international plays, right? You see news about them in Abu Dhabi, in the UAE, and Japan, and Korea. It makes sense, right? You can't put all your eggs in one basket. You can control what you can control about engineering the aircraft, but at the end of the day, you got to make sure that you can keep the company going and also capture these markets that are going to be there regardless of whether the FAA certifies your aircraft or not. So they're making
Do you have a
making
sense?
pushes there.
Do you have a sense for it's easy for us to be US centric, obviously, because that's what surrounds us every day, but the world is huge. And do you have a sense for, are there areas of the world that are much more forward thinking and much more on the cutting edge of wanting to use this type of thing? I think of Asian markets.
Yeah.
What do you guys see in there? Because I think a lot of times, whether it's bullet trains or whether it's EVs themselves, a lot of times these other countries are way further ahead than we even realize.
Yeah, they all are sort of accelerating at their own pace. I think you see a willingness to lean in that may be slightly at the same speed, if not faster, in the Middle East, UAE, Abu Dhabi. I think in Asian countries, you see also a willingness to lean in, but also a very high safety standard. And so in Japan, there's a thoroughness behind it before you can actually um, kick off some of these flights. But there are these sort of one-off initial routes envisioned between Tokyo and some of the countryside. Korea too. Korea is really interested and invested in looking and seeing how they can fly from the city center inside Seoul out to some of the further out districts more south. Because if you've ever been to Korea, you have the river. I think it's the Han River, and then you have Seoul Center. And every day when you either are traveling in or out of the city, in the beginning of the day or the end of the day, traffic is just crazy. Like I've been stuck inside a bus for almost 2 hours because traffic is insane. So they're keen to be able to fly, but there's also challenges in airspace because the way that the airspace is governed there, it's tightly coupled with their military. So there's all these sort of like very unique local challenges that show up differently at a global scale. And both Archer, we're now many years past, our Elevate days. And so the strategy that a Joby's taking is very different than an Archer, which is also very different than a Beta, right? Beta is going cargo delivery first. They're going to certify that CTOL aircraft first. They probably still have a lot of things they need to go do before that aircraft can VTOL properly and reliably. in the same way that a Joby or an Archer eVTOL can. So they all have sort of set their and established their strategies, and they're evolving in different ways. So I think it's kind of cool seeing how now they're leaning into their strengths, and at some point the market will show us which of these strategies plays out well, and where investments could have been placed, slightly differently in order to get to more favorable outcomes. I guess the last thing I'll say, and well, maybe not the last thing, but the other thing, there's a reason why I'm not talking about other folks outside of Joby, Archer, and Beta. We're going to see consolidation. We're going to see companies fall through because these days the cost of capital is quite high. It's not so easy to ask a SoftBank or ask a Tiger Global for capital to scale an eVTOL business. And frankly, there's players that have been around for a while that have not hit the mark. The folks like Overair, um, we're seeing people leave companies like that. They may potentially get scooped up by someone else or just completely fall away. Kitty Hawk is another example, right? Kitty Hawk had a number of years over many of these players, was capitalized by Larry Page, had contracts with AFWorks, but at the end of the day, that company, that startup, just did not make its way through to end markets. So we're going to see some consolidation. The people that are able to keep, a pretty nice war chest, be able to weather the storm, and then continue to advance and show meaningful progress towards air mobility that people actually want and will pay for, those will be the winners.
I think it's very reflective of the vehicle space on the ground. I mean, there's a much larger demand on the ground, and companies like Fisker and companies, I mean, even charging station providers and all of these people try to enter the space, and it's not. I mean, there's a lot of consolidation, a lot of technology improvements, and the best will win when it comes to those things. But it's you're not seeing any startup that wants to make an electric vehicle thrive. They're capital intensive, and a lot of times, I mean, even the ones that are thriving are still figuring out how to get their margins to the right places with economy of scale. Tesla seems to have done it right, but you see these earnings reports where Ford and some of these other large players are injecting lots of capital to get themselves in the production place to make profit make sense, with these vehicles. And the exact same things with aircraft. I mean, it's the chicken or the egg, what comes first. But in the airspace, the technology is coming, but it's going to have to be backed by lots of financial funding. I mean, you have Archer being backed by Stellantis, you have Joby being backed by Toyota and Uber and some of those other ones, and then Beta, obviously has a lot of order banks and investing going on into them. But it's taking hundreds of millions and billions of dollars of investments to get these companies off the ground, both literally and figuratively. And that's something that these little companies, I mean, Pipestroll and some of those ones that are getting product made and released and in the air, sure, they may have their place. There was another one that's like the hover plane. I forgot what the brand was.
Well, the cool thing is like Pipistrel was recently acquired by Textron. Textron's a pretty big, player,
Yeah.
right? They own Bell, they've got Beechcraft.
It's about having the right connections and the right partners.
That's right. The strategics will end up playing a bigger role in this. And I think we knew this for a very long time going in, but seeing it play out, and seeing sort of the delta between those that are well capitalized and backed by strategics versus those that can't make it all the way through, pretty significant. And you can't take it for granted either. So Alon had your strategics, I mean. Alon had from the Air Current recently published an article about Overair and their connection to Hanwha. So Hanwha is a pretty big Korean company, led the Series A financing for Overair, back during our Uber days. And despite having a pretty large name behind them, still couldn't make it all the way through. They are facing challenges, and I think again, even if you've got that big backer behind you, it comes down to being able to make meaningful progress. If you can't show that the capital is being used well, that you can get to flight, that you're hitting milestones that you set for yourself, it doesn't matter who you are as an investor. It doesn't matter how large your name is. It is not, financially a good decision to continue investing in a horse that's not going to move. So,
And one of the things that Josh mentioned was in the EV space, how some have struggled where others have thrived, and some of that, and even going back into COVID, had to do with supply chain and where you could get things, and the cost of a lot of vehicles really skyrocketed when we had that struggle with being able to get.
chips.
Yeah. So how much of what you're looking at in your technology is kind of agnostic of regions, so that people might be doing manufacturing in Europe, in Asia, in the US can all get the supply chain? Or is there a factor or a component that's really required and can be difficult? Like what's that look like in terms of when these companies go to try to manufacture these in different areas of the world? What's the supply chain like for the critical components that make this work?
Yeah, it's a really great question. For us, we're thinking strategically about where we want to source components. And first and foremost, because we service not only commercial needs, but also the DoD, we think critically about where motors are coming from, and some of our boards for motor controllers, and even the raw materials. Where are those raw materials coming from? Because it does matter to our customers within the DoD. And so for us, we built up. Not only did we have the challenge of starting the company during the pandemic, but we've also had this added sort of constraint of making sure we're DoD compliant. What that has meant for us, though, is we've built up a pretty robust supply chain. We know it's something that is compliant. We've got materials that we know are solid, can be certified safe to fly, and we've passed flight test reviews with the Air Force. So on our side, we just make sure that we're not sourcing components from sensitive countries. And then on the commercial end of it, if we're licensing to folks, we do make sure that even the folks that we're licensing to, they don't have either business practices or that they have the right firewalls and cybersecurity to ensure that some of the tech that we may be licensing out to them doesn't fall into the wrong hands. When it comes to some of these other players, like market wide, I think where you see a lot of this kind of get tricky is in terms of batteries, but also motors, magnets. Where are you sourcing your neodymium? And then outside of that, let's say you do have the materials. Okay, well, where are you actually going to manufacture? So, some people have invested a lot of money into vertical integration, like Joby. Beta also does this too, where they've developed a lot of things in-house. But strategically, there's going to be times when you have to go and find suppliers. And I think more often than not, people are looking towards reputable suppliers. And you're forced to do that because of the certification process.
In the airspace, it's all a little bit different. It's got to be a little bit more, I think, streamlined, if you will, because of that technology. But I mean, Whisper, you guys specifically are primarily focused on engineering the technology and then partnering with those, like you said, like you design the leaf blower, but your goal is not to be a leaf blower company. It's to then take the technology and source it out. And the same thing goes with the aircraft. I mean, you guys are wanting to take your technology and incorporate it into a OEM that could basically manufacture that aircraft with the technology, correct?
Yeah, the difference is in aerospace, we'll build the engine.
Yeah.
We'll build that propulsion unit. We'll make sure that it's got the right motor controller and operate the way it's supposed to. And then we'll work with that team to ensure that it's integrated properly. That
An
when they go,
Airbus has a GE engine. I mean, it's just
that's
you
right.
would be the engine provider in that situation.
That's right. Whether it's Pratt Whitney, Rolls-Royce, GE, that's who Boeing and Airbus look to when they develop a brand new aircraft. And so as we start to move into this next few decades, as we electrify, I think more and more we're going to see some of these airframers and OEMs look at Whisper as as first an option, but then the option for cleaner, quieter, more efficient thrust.
I mean, I don't
Whisper
think
Aero, the new Rolls Royce.
that's it. The Rolls Royce of the air. But
Heck yeah.
I mean, efficiently though. I mean, there's not really many people. I mean, people are slapping whatever technology they can get onto their aircraft and just making it work. There's very few people looking at how do you make this quiet or how do you make this more efficient. And honestly, that's what the space needs. I mean, to promote the future of advanced air mobility, we can't have a million drones flying around that are just loud, noisy, and inefficient. I mean, you need to have this consideration because the efficiency, like we said at the beginning, affects the range, but also the consideration aspect for the thrust technology will help promote the future of the industry. So I think what you guys are doing in the space is incredibly important.
Yeah, markets just naturally drive towards specialization, right? So we know that this is a key component, and we're going to own propulsion, and other folks are going to own the integration piece, and other folks are going to own the operations piece, and that's great. We're going to build a better product because of it.
Absolutely. Well, we've run up to almost an hour on time, and I don't want to overextend Grace, and we can continue this conversation for hours, and there will be subsequent conversations about everything that you guys are doing. But do appreciate your time and your insight. I mean, the realm of advanced air mobility excites all of us. I think anybody that hears about it, they either have curiosity or they're just unwilling to learn the excitement that the space is bringing. But seeing the technology with your own eyes, and just the practical applications, like we said, all the way down to the leaf blower is an insane and very cool thing to see how what you guys are doing is implemented on multiple scales, but what that's going to mean to the future of the industry. So very unique, very awesome. Excited to be partnered with y'all. But anything else anybody else wants to add before we close this out?
I just think it's exciting. I mentioned pre-show how I used to do private aviation with Cessna 172s, and just the idea of being able to go down to my local regional airport at some point in my lifetime and jump into a quiet aircraft and just take off and enjoy a flight around the Bay Area, up to Napa, down to Southern California. Just for I know there's all these other exciting DoD type things, but just selfishly as an enthusiast of aviation, someone that grew up as a kid, in love with the SR-71 and NASA and space, and the idea that I could be up in the air myself, and do it in one of these, and Josh mentioned earlier about, and I think you did too, where, in my Cessna, when an engine failed, which fortunately never happened to me, but you're always training for it. You're always thinking about soft field landings. If I would land on a freeway, you're constantly having to look and plan for where's my bailout scenario.
Yep.
And you're to have all of that efficiency and have those multiple engines, and just to think that in my lifetime I could see that and climb into one of those is really inspirational. And I think that some of this stuff is going to inspire so many kids in the same way that I was inspired early by great technology. And so can't wait to see where this lands. No pun intended.
Lands, yeah. I would encourage you to go back and listen to our original episode. I'll link it at the end of this video. But I mean, the conversation of connecting the regional mobility push, which is what Whisper's vision has been, is that regional mobility. This isn't as much the eVTOL, which is, for the listener, the vertical takeoff and landing, like helicopter type aircraft. This is, you take off from your regional airport and you can go to another regional airport cost effectively. And that's going to really open up regional mobility. Because, for Jesse and I, for instance, there's no Tennessee to Tennessee connecting flight at all across the whole state.
Oh my God. Driving from Nashville to Johnson City that last time.
It's terrible. I mean, and that's
insane.
what we've had to do it 100 times in the last year. And, if I wanted to fly to Nashville, it's going to take me 8 hours in the airport system because I have to fly to Atlanta, get to the next terminal, the security check-in, and get over. Like, if I could fly directly from Tri-Cities to Nashville, I would do it. I would have done it 100 times by now. But the cost is the consideration, because a two-person can't fly without being $5,000 with a private plane. But the consideration for small aircraft, air taxis, regional air mobility, all of those things really is the future of transportation. Because, the roadways are getting congested. We have packages and tractor trailers and all of this stuff. We talked about this on the last episode, but we have congested roadways and we're trying to figure out how to improve that. The skies are wide open. do it considerate, do it cost effective, and it's going to be the future of mobility. So it's an
Yep.
exciting space and a lot more to talk about. So
We're gonna make it happen. We're gonna make it happen. And the one last nugget I'll leave you with is yes, we're gonna make regional air mobility happen, but at some point our tech will be in eVTOLs also.
yes, absolutely, absolutely. And I mean that's a needed space too, because our first applications, for we Jesse and I look at the charging infrastructure for these aircraft, Archer and some of the ones that are coming out, and the first application is urban mobility, but Nashville's one of the most congested cities in, in the nation, and per capita, it's one of those things that, like, how do you decongest the roadways of Nashville? Hey, if you could have somebody land at B&A, which is the main airport, and be able to shuttle into the stadium, well, then all of a sudden you're taking stress off the roadways. And if you could move your packages from the FedEx hub over to 5 or 6 strategic delivery points, you're spreading out traffic. And so the use case for eVTOLs is there, but eVTOLs may not be the application to get you from to East Tennessee to Nashville, but the conventional takeoff and landing aircraft, that's where it makes the most sense. So there is a beautiful play for all of them in this space, but definitely something that we're got to get the technology out and released, which I think those eVTOLs will be here as soon as next year. And then, get these regional air mobility, conventional takeoff and landing aircraft functioning in production. That way we can actually start getting some better mobility solutions. So
Right on.
well, there you go. Thank you again, Ian, for coming on. We will have you on again, give you a next year update whenever, and if we get other questions from listeners, we'll bring you back on. But thank you so much for your time, and that is all for today. Tune in next week for more EV news and updates. Thanks for tuning in to Turn Down for What. Tune in next week for more EV news and updates. Make sure you're subscribed with your notifications on to be notified when we post more episodes like this one. See you then.